Good morning, guys. This is Chapter 4, Lesson 2, the answers on wave properties. Your first question, you were to summarize amplitude and energy. The amplitude of a wave is the maximum distance the particles in a medium move from their rest position as the wave passes through the medium. The larger the amplitude, the more energy the wave carries. This next part, analyze how amplitude is changed by energy in a transverse wave and in a longitudinal wave. So you were supposed to redraw these, or try to, see how it has changed. So this one, if you add more energy, it's going to be, the amplitude is going to be taller, more, so the amplitude is from here to here or from here to here. So here's your amplitude. If you drew one, you just need to make it taller, lower in the trough, higher in the crest. So it indicates more amplitude, so more energy. So transverse waves, the crest would be higher, the troughs are lower. In a longitudinal wave, having more energy, these refractions are going to be further apart. Try to draw this. And the compressions will be even closer together. So the coils are closer together in the compressions and the farther apart in the refractions. Okay, on the next page, you were to model two transverse waves, one with a short wavelength and one with a long wavelength. Identify the crest, the trough, and the wavelength for each wave. So hopefully you drew something like this. Here is a shorter wavelength, and here is a longer wavelength. So here are the crests, some troughs in each one, the crest up here, over here, and a trough. Like wavelength, remember, it can go from crest to crest, is how I did it, or it can go from trough to trough. Then you were supposed to do the same thing with longitudinal waves, one with a short wavelength, one with a long wavelength. Remember, in the longitudinal waves, the wavelength is going to be all the way from the rarefaction through the compression. So here would be a wavelength in this short one. Here's some rarefaction, here's compressions. This is repeated here with a rarefaction and compression, so this is another wavelength. If it's spread out, you're going to have a longer wavelength. Here you have more rarefactions here, and then your compressions. Here's another start of a rarefaction on this side. Alright, down here at the bottom here, frequency. What is frequency? The number of wavelengths that pass by a point each second. We measure that in hertz, which is capital A, little z. And what is that hertz? It is the number of wavelengths in 1 second. So it would be something over, a number over seconds. And the last page, relating frequency and wavelength. If you have a rapid vibration, it's moving very rapidly up and down. Try to draw it here. This is going to have a high frequency with shorter wavelengths. If it is a slow vibration, it's going up and down slower. That's going to be a low frequency with longer wavelengths. Okay, wave speed depends on the medium. That's what it's traveling through which it passes. Mechanical waves are going to travel faster in solids. This is like sound and stuff. Travel faster in solids, slower in gases. They also travel faster as the temperature increases in whatever they're going through. Electromagnetic waves like sunlight, radio waves, microwaves, things like that, X-rays, they're going to actually travel faster in empty space and slowest in solids. How do we calculate wave speed? In meters per second. If you know your frequency, which is something over seconds, you can multiply that by the wavelength in meters. Here you get your meters over seconds, so it's going to be meters per second. So you just now that looks like a plus sign. It's supposed to be multiply. You multiply those together. Alright, contrast the amplitude and energy of waves you make when you shout across the room with the sound waves you make when you speak softly. Here's a sample answer. When you shout across the room, the sound waves have a greater amount of energy, therefore greater amplitude, than when you speak softly. Softer sounds have less energy, and therefore less amplitude. Okay guys, that's it going over lesson 2, and I will put the quiz out on Classroom shortly. Thank you.